Alright, here we're going to talk about congruent triangles. So congruent just means that they're equal in geometry. When we're talking about triangles, that means we have the exact same triangle. So the congruent triangles have the same side lengths and the same angle measurements. So two triangles are congruent if and only if every part from one triangle is congruent to its corresponding part in the other triangle. So corresponding just means matching part. So AC here matches up with DF. Those are called corresponding parts, those two, and they are congruent to each other because these two triangles are congruent. That's what this is saying. Triangle ABC is congruent to triangle DEF. The order there is really important. A matches up with D. C matches up with F. And B matches up with E. Those are corresponding vertices, and it's written in that order. A and B and C correspond with D and E and F respectively. All right, saying this in a shorthand way, although at first it's not going to seem shorthand, corresponding parts of congruent triangles are congruent. The matching parts of congruent triangles are also congruent to each other. We have an abbreviation for that. It's CPCTC. So all the matching parts have to be congruent to each other. So I'm telling you that these two triangles are congruent. PQS, RQS, those are congruent triangles. Actually, let's start with that. I'm going to write the congruency statement here. PQS is congruent to RQS. The order of one of these doesn't matter, but if I'm going to say this in this order, PQS, then I have to say the other one in that same order, RQS, because these 2 points match up with each other. They should be in the same spot in that congruency statement. All right, so we have two congruent triangles. We want to just list out all of their congruent parts. So PQS, that angle is congruent to RQS. Those are matching parts in those two triangles. You can see that's the exact same thing as what we had here. That's going to happen. PSQ, P to S to Q is this angle. That's congruent to RSQ. QRS, QRS, 1, 2, 3. So I'm going to put 1, 2, 3 in that angle to show that those are the same. That's QPS. PQ is congruent to RQ. PS is congruent to RS. And then QS is congruent to itself. That's the third side in both of these triangles. QS is congruent to itself. And that might seem pointless right here, but when we get into proofs, that's going to be really useful. This is called the reflexive property. I would write that right now because this is going to come up a lot. The reflexive property just says that we're able to say that something is congruent to itself, which kind of seems pointless, but when we're talking about these two different triangles, if I say that QS is a part of this triangle and QS is a part of that triangle and it's the same QS, that means I can use it to prove that these two triangles are the same. So we can use it as part of our proof, saying that that side is the same as itself, using the reflexive property to show that we have one pair of congruent sides. That's going to make more sense when we do some practice problems. All right, so for right here, no proofs involved. We're just trying to say all these congruent parts in these two triangles. So KM, that's this length, that is congruent to AC. CY, that's this one, that's congruent to MP. And then PK is congruent to YA. We're just really finding those matching pieces. Honestly, we don't even need the picture. We can see it right here. KM is congruent to AC. Or CY, C to Y, is congruent to M to P. The order here really tells us everything that we need. So angle Y is congruent to angle P. K is congruent to A. And then ACY is congruent to KMP. Now we're just talking about these triangles, just written differently. So MPK MPK, it's just written backwards there, so we're going to write this backwards also. CYA. And then YA, Y to A to C is the same as P to K to M. Oops, sorry, that's supposed to be triangle, not angle. P, K, M. This is really just emphasizing that the order does matter and they match up. All right, here we're given that these two triangles are the same. PHC is congruent to C and F. We're going to find the values of X, Y, and Z. All right, so this angle matches up with this angle. C. Oh, I'm realizing I wrote that wrong. That's got to be an S. Nope. That's wrong too. No, that's okay. Sorry. That one's okay. C matches up with P. And then S matches up with F. All right, so your first thought might be thinking these have to add up to 180, so I'll set up an equation. Problem is that's two variables in one equation, so we won't be able to solve that. But we do know that corresponding parts are the same. So C and P are the same. So 4Z minus 32 is equal to 36 degrees. Those have to be the exact same angle. Actually, let's just solve this. Adding 32 over, get 68, and then divide by 4, and we get 17. So Z is 17. Next one I see is that H and N are corresponding parts, so those two are also equal to each other. So we can add that 29 to both sides. 134 equals 6x. And then we divide by 6, that would be 24. Last one, here we actually are going to need to use the fact that they add up to 180. So N is 115, that means H is also 115. So 36 plus 115, that's 151. The remaining part of the 180 has come from angle S, so that's 29 degrees. So angle S is 29 degrees. We know that S and F are the same, that angle and that angle, so I can set up my equation. 3y minus 1 equals 29, so y equals 10. All right, so this is one way that you could justify that these have to be the same. Sometimes it says what value of x will force these to be congruent. Sometimes it says they are congruent, find x. This is the simplest version of proving that triangles are congruent. Really what we're mostly going to be focused on is these congruency theorems. So each of these 5 can be used to prove that we have 2 congruent triangles. They're all abbreviated, and they're all abbreviated in a way that really makes sense. It tells you exactly what we're using, what information we're using to show that these triangles are congruent. So our first one is side, side, side. We're abbreviating that as SSS. That means we have 3 pairs of congruent sides. So in these triangles, I'm just going to mark exactly what that says. That one is congruent to that one. That guy is congruent to that one. And this one is congruent to this one. We have 3 pairs of congruent sides, so these 2 triangles have to be congruent. Our second one is side angle side, abbreviated as SAS. The order here is important. It's saying a side, another side, and the angle that's in between those 2 sides. The way that we say that in math is an included angle. So 2 sides and an included angle. Doesn't matter which 2 sides. Let's pick this one and this one. So I have my 2 sides that are congruent to these 2 sides. An included angle is the angle that's sandwiched in between those 2 sides. These 2 sides, in between those, we have that angle and that angle. That's a side, an angle, and a side. It's in that order. You're wrapping around the triangle. The direction you start and the direction you go doesn't really matter, but I'm imagining looping around this triangle and labeling this as my side, my angle, and my side. And those same corresponding parts in the other triangle have to be congruent. Side, an angle, and a side going around the triangle. ASA is angle, side, angle. Same idea. We have an angle, another angle, and the side that's sandwiched in between them. So 2 angles and an included side. Doesn't matter which 2 angles. I'm going to pick this one and this one. So if those two angles are congruent and their included side that's sandwiched in between them, those are also congruent, then we have congruent triangles. Again, it's just imagining going around the triangle using this acronym: angle, side, angle. And you can see the order really doesn't matter. If you started at this one, you could still say angle, side, angle. AAS is angle, angle, side. So we have an angle, and then a side that's not sandwiched in between them. We could say that's a non-included side, or maybe a side that's opposite them. So any two angles, let's pick this one and this one. And we're using one of the two sides. It's either of the sides, a side that's opposite them. So really pick either one. I'm just going to pick that one. So that's an angle, angle, and a side. Angle, angle, and a side. This example, I'm wrapping around going that way if I wanted to. You could also choose this side. That's the exact same situation, but we're going the opposite direction. We have an angle, and the side that's not in between them. Angle, angle, and the side that's not in between them. The last one is called hypotenuse leg. So we need the hypotenuse and any one leg of the right triangle to be congruent. There's more built in there than it might seem. Right triangle also says that we have a right angle. We have a 90-degree angle in the triangle. So we really need three things, even though we only state two things. If we have a hypotenuse, that means it's a right triangle. So there also has to be a right angle somewhere in here. So we really need three things for this. We need a hypotenuse, a pair of hypotenuses, a pair of legs, and two right angles in those triangles. So we have a right angle. We would definitely need the hypotenuse, so it's got to be that one. Hypotenuse is always directly across from the right angle. So we need the pair of hypotenuses, and either leg, it doesn't matter. I'm going to pick this one. But those three pieces, the right angle, the hypotenuse, and one of the legs, that's also enough to prove that we have congruent triangles. All right, so we are looking for any of these criteria to decide if we have congruent triangles. So which theorem can we use to prove that these triangles are congruent? We have an angle that's congruent to this angle. We have a side that's congruent to this side. And we have an angle that's congruent to that angle. And it says it directly right there. It's angle, side, angle. We have an angle, another angle, and the side that's sandwiched directly in between them. On the next one, this right angle might be confusing. It might lead you to believe that we have hypotenuse leg here, but there is nothing shown about the hypotenuse there. Remember, it's always across from the right angle. There's nothing shown about that. So we're not going to be using hypotenuse leg. And it might be confusing here because it seems like we only have two pieces of information. We have these two sides that are congruent. If this is a straight line, we have an angle in this triangle that's congruent to an angle in this triangle. So we have a side, an angle, and then it seems like nothing else is given, but the reflexive property says that that side is congruent to itself. So this side I can mark with those two marks saying that it's just congruent to itself, but that's the third piece of information that I need. That is a side. It's also a side in this triangle. So I have a side, an angle, and a side. Again, the order comes from where that angle is located. It's sandwiched in between the two sides that are congruent. Number three, we're going to have to use the reflexive property again. I see this side in the middle. It's congruent to itself. So I have a side, and a side, congruent to a side, and a side. That is called side, side, side. Right, on these last three, we're looking for what information is needed to prove the two triangles using the given theorem. So we want to use this theorem. We don't have enough information right now, but we want to say what other information we need to show that these triangles are the same using that theorem. All right, so I'm using angle, side, angle. First off, I'm going to mark that this side is congruent to itself. That's not additional information that's needed. That's information that's provided in that picture. Using the reflexive property, UT is congruent to UT. So now I have an angle, a side, and I need that second angle. It's got to be this angle. And in that bottom triangle, it's an angle, a side, and it's got to be this angle that's congruent to its corresponding part in the other triangle. So the additional information I need is that part. SUT, angle SUT, has to be congruent to DUT. If that were marked there, then I would have my angle, my side, and my angle, exactly what I need to show using angle, side, angle. Okay, now I want to use side, angle, side. So I have a side here that's congruent to itself. I have this angle. Really means I have to go that direction with it. It's side, then an angle. I have to go to the next side over here. That's got to be WV. It's congruent to same kind of pattern there. WV, KX. We have a side, an angle, and a side. Last one, now we're using hypotenuse leg. So we have our right angle, we have one of the legs. Gotta have that hypotenuse, so it's gotta be BC is congruent to KL. Alright, that should get us started on congruent triangles.